to have a timer, have a clock running. And the amount of time that passes between each game loop is called delta time. That's the change in time. And we use that to control the physics. We use that to maintain frame rate independence. In other words, I can run this program on this computer and it runs at the same speed that it does on my old whatever single core laptop. Yes.
You said have to start off at game. So we should create a player in our game constructor or every time we enter a game.
Either way. Land School got shut down. Hold on. All right. So to set up delta time, we're going to set up a variable. We're going to make it global because delta time is used everywhere. And so you can head over to globals.h. This is what you should have as a minimum. You may have even more than I do, but we should have at least this stuff going right now. So let's add a few other things. I'm going to go ahead and add everything that's needed. Like I said, we're going to be using some trig. With trig, SDL likes to keep track of angles in degrees, you know, 0 to 360 degrees. But most of your math functions, in fact, I think all math functions prefer angles in terms of radians. And so if you're taking sine or cosine of something, you need to pass that angle in terms of radians. And if you're passing it to an SDL function, like a draw call, you're going to want it in degrees. Now you can choose whichever you want for the standard, but I chose degrees to be my standard, and I will convert to radians as needed. So to do that, we're going to set up a variable for pi. So we'll just pound define pi equals 3.14159.
You just know that off your head?
Yes.
It's pretty nice. Or genius.
Wow, I memorized 5 numbers.
All right, Ellie. You're pretty dark over there with all that shade you're throwing.
Yes. And we'll get us a double for delta time. And I just call it delta. You can call yours interpolated loop timer thing
A double.
if you want.
What about an accuracy of double?
Well, that'll be all right. I don't know what that is. I doubt it's bigger than 64 bits. So, is everyone okay with their globals?
Yes.
Feel like we're on par here. What? All right, for the extern, you'll need to initialize that somewhere. I'm going to initialize it where I initialized all my other externs. So I'm going to state.cpp. Some people may have done this above main, that still works. But then I like to initialize it to .0.001. If you initialize it to 0, it sometimes causes issues because anything multiplied by 0 becomes a 0. But 0.1 is really close to what delta time will be on these computers anyway, so that should be fine. All right, now we're wanting our goal right now. Like I said, hopefully you've got your game states up. You've got a background in on the game state. That's fine. You can take the buttons out at any point. We're not looking to go back to main menu, so you could comment those lines out. But we do want to get a player on the scene. So you should have a player class, and you should have an object class. Let's look at the base class first. We should have a few things in here. I'm going to include my globals. And I'm going to include my vectors. And this is the vectors that you wrote, not the one that is a container. So whatever you named your vector header file, that will need to be included there. I'll have to export mine over from the other project because I forgot to move that one. I'll do that in a minute.
You're recording this, right?
Yes. All right, we said all game objects are going to have a few things in common. One would be a texture. So you should have a texture pointer here for that. You need a rectangle. Now I said do source and destination, but if everything has its own sprite, like if your ship and your bullet and your asteroid are all on different PNGs, there's no need for a source. We can put in null and it will just bring in the whole thing and that'll be fine. So I won't have a source and destination, I will only have a destination and I'll just call it rect. A few other things that we need. Maximum velocity for any given object in the game. We don't want anything going too fast, so it becomes important to put a Vmax on here. So that's what that is. Also, we want these objects to be able to rotate. Ship should definitely rotate, asteroids should rotate, maybe you want your bullets to spin if they look like cool Chinese stars or something like that. So we'll put in an angle. And then for physics-based motion, you need basically three things in terms of 2D vectors. You need a position, a velocity, and acceleration. Every object will have some x and y location. It will have a velocity with the x and y direction, and it'll have acceleration, maybe, as needed. What is the difference between acceleration and velocity?
Acceleration is the rate at which you increase or decrease in speed.
Right.
It's changing velocity.
Change in speed, change in velocity. That's the best way to think about it. If I'm speeding up or I'm slowing down, I am accelerating. If I'm sitting still or I'm cruising at a steady speed, I am not accelerating. That's the difference. Let me pull over my file so that my program's not so angry with me. So we go with object. Now we said player was going to be derived from object. Right, so you should have a player class. We'll look at the header file first. Our header file is going to include, by inheritance, we get everything we just put in object, but the player needs a few extra things. One thing it's going to need is a vector of bullets. So we will pound include bullet .h, and we will include vector. This is the STD vector, which is the glorified array. Alright, so bullets, if we want to make a vector of bullets, how do we do that?
Vector pointer to bullet. And then there's like bullet, lowercase, and then brackets 10.
Whoa, 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 whoa. You made an array of vectors of bullets.
But this is your fault. You did
Yeah.
that in one day.
Did I?
Yeah.
That you did.
I think you are all making this up.
No, you're not. Allie.
Even if I did it wrong.
Using namespace.
Yeah, you can do it using namespace, or you can use the scope resolution operator. I don't know if we'll need it again, so that might be quicker.
Okay, wait, what?
What's that? I said it might need a hitbox. You could use the same hitbox that the image is drawn on, but your collision is going to favor the enemy, and that's generally a bad thing in video game design.
Do the bullets really need to be pointers?
Do they need to be pointers? I think so. It's more efficient. I can't hear you.
Where does the array come in with the vector bullet?
Where does what?
We took out the 10 bullet arrays, making it to the vector declaration. Where's the array going to go when you ask for an array, a vector of 10 bullets?
You're not going to have a vector of 10 bullet arrays. You're going to have a vector of bullets. Now, a vector is an array, and it will hold as many bullets as we want to put in it.
A vector can also be an array of arrays.
Yes.
That's where I got confused. Okay.
Yeah, don't do that.
So in the project, you call for at least 10 bullets, a vector of 10 bullets per player. Is there a way that you can define capacity for this vector, or do we not need to?
We don't need to right now. What you could do is you could try to initialize it right here, or maybe later on even. I don't think it'll let us initialize it here. If we did that,
Doesn't?
no.
It always gives you errors.
Yeah. So it's not going to let you execute the constructor in the class declaration. In the constructor, we could say bullet equals vector bullet and then do it there. And I tried that, but even if you put in a new bullet, they're all the same bullet. So it initialized the entire array with that one bullet, and then I only had one bullet even though I thought I had 10. So that was a bug. It took me a little while to figure out. So let's just go with this for right now, and then we'll initialize it in the constructor. We've got a hitbox. We're going to need a few other things. If you want a machine gun, you're going to want a rate of fire. Okay? If you want to just be able to hold down the button and shoot an array of bullets, a different array, a volley of bullets, then we'll need a rate of fire. Otherwise, you shoot them all exactly the same time and they'll be stacked up on top of each other and it's not as cool. It hits really hard, but it's not as cool. And we'll need a timer to keep track of, how much time has passed since we last fired a bullet. We'll need a score. I don't know why I did unsigned here, it's not important, but I figured your score should probably never go negative, so why not? And then we need an update function, a create bullet function. I'm missing a boolean to keep us alive.
Draw.
Draw. You need your draw.
Well,
And enter.
Or
We can pull draw from the base class. Is that what you said? Yeah.
Doesn't need to be in all the.
I don't think it needs to be in every object. I kind of wished I had put it in bullet, but I did just pull from the base class, so we'll probably do that. One more variable that might be cool is the force. This is so you can adjust the force on your engine. You don't have to do that. You can hard code it if you want to.
No.
That's pretty good. Now, someone said draw. We can just write draw in the base class. So let's go back to object. And let's see, what else do we have going on here? We're going to need a virtual void update. Virtual void draw. And if you want, you can define that right here because it's a one-line deal. SDL underscore render copy. If you want to include angles when you're drawing stuff, you're going to use render copy EX instead of just render copy. This is the extreme render copy. And the first 4 arguments are the same. Like I said, we're passing a null right there because we're not going to use the source rectangle, we're just going to use the entire image. And then we'll put in the rectangle for our destination. We'll put in our angle. This next argument is the point of rotation. So if you wanted to rotate around, let's say the top left corner or something like that, you could set up a point somewhere on your image and it would spin around that point. By default, it's going to spin around the center, and that's normally fine. So you can leave that null. And then if you want, you can flip the image. We're not going to do that, but this comes in handy for like side scrollers. You can flip an image horizontally or vertically right there. We're not going to flip it, so put SDL flip none. So this draw call will handle the drawing for every object in the game.
Is that what EX actually stands for? Is extreme?
I have no idea. Sounded good. That should be address of rectangle.
It's saying SDL at the top EX.
You have globals included at the top.
Yeah.
Make sure you spell it correctly.
So if we want our asteroids to rotate, then our draw would be a little different for angles.
This handles to that. That's why we put the angle in. We don't have to redefine draw for every object. This will work across the board. For update, I don't think I ever defined that with anything fancy, so we may just define that here as well. Yeah, you can define that here as well. All right, we good? Moving on. Back to player. All right, we need definitions for update and create bullet. And we need our constructor right there. So let's go to players.cpp. And in the constructor, we're going to initialize everything for the player. Texture, load in a texture. Anytime a player is created, this will be done. I called mine player.png, so you'll put whatever file name you called your player right there. Now, some of these lines dealing with vectors are banking on the fact that you overloaded them correctly. I'm going to set my position initially to 0. That only works if I have overloaded this operator. If I haven't overloaded that operator, I will have to do this. So if you get an error when you try to do that, or your ship doesn't behave correctly, it may be due to bad overloads or lack thereof. Alright, position vector is initialized to 0. That means I'm up in the top left corner. Velocity and acceleration, go ahead and put those at 0 as well. Angle can start at 0. And my rectangle, I need to initialize to my position. This is what I was talking about on the board earlier. We want to put the rectangle at the same position and then subtract the half width. This is scooted over so the rectangle is actually centered on the position. I'm only using the destination. I decided we don't need a source if there's no sprite sheet. So if you have destination, this will be destination. And you'll need to define the height and width of your rectangle. So however big your image is. And then Vmax. This is the top speed of your spaceship. You can experiment with this number. 100 is a good starting point. If you want your spaceship to go really fast, you crank that up. If you want it to go a little slower, you bring it down. But this will be the governor that sets it from going too fast. Because, you know, it couldn't go as big as the variable will allow it. Engine force is another one we want to set. And again, you can come back and play with that. If you decide it's too sluggish, you want faster response time, you can bump that up. And now, we talked about the bullets. We need that array of bullets, or that vector of bullets, filled up. So just write a for loop. This is however many, this is your magazine right here, however many bullets you want to put in there. And then do you remember how to do this? How do we add bullets to the vector?
Push back.
If I use the constructor to initialize the vector, it just it stuck this one bullet in there 10 times, and that was bad. So I had to use a for loop to get it to work correctly. And then we can set our fire rate. I set it to 0.1. That's a good starting number. You can again adjust that later if you want to.
So, where I say new bullet, it says object of abstract class type bullet is not allowed to your virtual function. Object enter has no overrider. I don't know, man.
I haven't really done anything with bullet. It's just an empty class. What's up?
Is it supposed to be, for us, is it rectangle or is it hitbox?
We're not doing anything with hitbox right now.
Okay, so it is supposed to be right?
Yep.
So it was giving me an error, right? That's what I was wondering. And now it's not. Okay, so
We're not doing anything with the hitbox until we get to collision.
now it's giving me an error.
Where are you? In the object draw function?
Yeah.
Where else would you be using a rectangle?
I don't know. It's,
Right here?
maybe I did that wrong.
You got to pass the address.
Oh, that's right. Yeah. And then it gives me an error for that.
Did you call yours rect?
Yeah.
So all this matches. And you included globals.
Yeah, no, it was auto, or it was IntelliSense kept doing
Yeah, do not trust IntelliSense. All right, where were we?
Good now.
Player, CPP. We've got all this. Do you understand this? Are there any questions about what we've done here?
No.
This is the constructor. This is what happens when the player is created. You've got to get all these things, initial values, get him all set up. He's up in the top left corner right now. That's okay. Now we need to define update. If you're going to be creating and destroying your player, you need to free that texture up in here, and you need to delete all your bullets. Alright, this is where the magic happens. You know what? Let's just make sure we can get this guy on the screen before we dive too far into updating him. So we've got the function definition here, but we will leave it empty for now. And go ahead and define create bullet. We'll also leave that empty for now. I'm going to make sure this still builds. Okay. I had still got a few hiccups here I'll have to come back and address, but we can move forward. Say that. In game, like I said, you can create the player here. I chose to go ahead and do that. Player equals new player. And I set my background image. So whatever you called that, you want to, if you don't already have this, y'all may already have that. I'm going to add the enemies right here when I get to that point. Update. Alright, we need an event. We need a bool to keep this thing running. We need, see, delta time. To keep track of delta time, we have to take note of the current time every game loop. So we'll create a double for that. Start it off at 0. And then here's our main loop. Alright, we're going to set delta time first. So set delta time. That is the change in time. Delta equals, and there's lots of ways to do this. You can use the CTime library, but SDL already comes with a way of doing this, so I just use that. SDL get ticks. And this is the number of milliseconds that have gone by since your program started. We subtract the current time from the time the game started, and then to get our time in seconds, we'll multiply it by 0.001. Like I said, this comes in as milliseconds, so this will take you back to seconds. And then you're going to set the current time so that you know what you're working with on the next game loop. And that's delta time. Alright, you should already have the pull event. So I'm just going to copy and paste that from my other project. If you need to update your poll event, it should look something like this. Alright, in the game state, we need, hold on. We're going to need to do a few different things. We're going to get keyboard input, right, so we can control the player. After we get our input, we're going to update our objects. We're going to check for collisions. We're going to draw. And then if needed, we could do things like play sounds, etc. And at some point, maybe check for state change, like in-game or victory or something like that. So that's the order. We're going to fill out each one of these things, at least some of them today. we probably won't finish, but we want to at least get the player on the screen. So we created the player. We've set him up at 0, 0. Let's see if he will show up. So under draw all the things, let's just try that. Player.draw. I'm going to change my starting state to gain because my buttons don't work in this version. Okay, so I'm missing a few things. I did the render copy, but I never did the present. And I never drew the background. So I want to draw the background before I draw the player. That'll give me a background. And then I draw the player and then I present. I forgot to present. STL render present. There he is. He's up there in top left corner, right where we put him. We can move him in a little bit. If we go back to the player constructor and set, instead of position being 0, let's set it at 100. That'll move it down and to the right. Should get him completely on the screen. There we go. I just changed it to 100. The 0, 0 is the top left corner. I could barely see it, but you can bring it in a little closer to the center.
So when you said player draw, player, you're referring to the player that you created in the game constructor.
Yes, that's this guy.
Yeah, for some reason it's saying it's undefined.
Same.
Even though I've followed.
I declared it in the game state. So if we go to state.h, we should have a player pointer there.
What if, so if we created the player in the constructor, is that an issue?
It destroys it when the constructor closes like any other function. You declare your variables in your class, and then you initialize them in your constructor. Does that fix it?
Yep.
Background was what? Right here?
Yeah.
That says the entire image to the entire screen. That's why I put null in there twice, because it's a background.
Wasn't the default game state already have that?
Maybe. I think that the base class has the background. What do you mean? All right, moving on, we got to get player controls in there. The first thing I want to do is be able to rotate this guy. So under Get Keyboard Input, we're going to set up a constant uint 8. And it's going to store the current state of all the keys. So this is going to check the entire keyboard. Any key that is pressed down is going to get a 1. Anything that is not pressed is going to be a 0. It's important to work with scan codes whenever you're doing games because you want that instant, I guess that instant key detection. You know, like if you're typing, it pauses if you hold it down, and then it will wait, and then eventually it will print an entire, section of whatever you're holding down, but there's a pause there, and that's really bad in gaming. Right? If I just hold down G, it gives me 1, then it waits a split second, and then it gives me the rest. You don't want that. So we work with scan codes whenever we're doing game controls in most cases. All right, that loads in the state of the keyboard every game loop, and then we can set up some if statements and check specific keys and then do things based on whatever keys are down. So let's try rotation first. Current key state, and then these are all enums from SDL, and you can look them up in the API if you wanted to know what a specific key was. I use the left arrow. What did I do wrong? State. So if the left arrow is pressed down, we want to rotate the player. How would I do that? No, we're rotating. Just rotate in place.
Reassign your angle.
Angle.
Does that work?
Of course it works. It's checking for a 1 or a 0, true or false. Anything non-zero is true.
So any button would make it true, then pretty much, right?
No, just this one. That index. And then we can do right. Dang it.
So this is the left arrow key, that first one?
Yep. Well, 100 is going to be your speed. I didn't put in a variable for that. You could if you wanted to, but know that if you feel like your ship turns too slow or too fast, you come back and you change that 100. Alright, so that will change the player. And we need to call update. And let's see if that does anything. should be able to rotate now.
Go back to your phone.
Where can we define the size of the player?
Yeah.
Size
Yeah, like the rectangle size.
in probably player CPP. Right here, height and width.
Are you having a problem where the entire thing's just taking up the entire? Yeah, mine is too.
Hey, Ellie, so what is this trying to do straight position equals
I wanna
zero?
know, I
It's
prefer
gonna be an error.
Thank you.
There's the overloads. Like I said, if you didn't overload those, you can still do it. You just have to do it individually. Where we want? Up? Up. So I used up to go, and this is what I was talking about earlier. If you want your guy to travel in the direction he is pointing, you can use unit vectors or you can use trig, and I just choose to use trig here. But the X of the player, how many of you guys have a knowledge of trig? You have working knowledge of sine and cosine? There's a few of you here.
I refresh a little bit. Like, yeah. Oh.
Looks good. So you've got some angle here, okay? This could be 30 degrees or who knows what. Could be anything. But you've got a X component. Say this is my vector. This is the unit vector, one length long. This will be some length, and this will be some length. To get the Y component, I'm going to take the hypotenuse, which is just 1, and then multiply that by the sine of the angle. That gives you this piece. And then for the X component, take the hypotenuse, which is 1 again, you multiply that by the cosine of the angle. That gives you your X component. And this is good for any angle that you want to point. Right? If you're staring straight down, your angle is 0. What's the sine of 0? 0. What's the cosine of 0? 1. 1. That means full throttle in the X direction, nothing in the Y, which is exactly what we want if we're facing that direction. And likewise, if we were pointing, straight up, the sine of pi halves is going to be 1. Cosine will be 0. So, armed with that information, we're going to change the player's acceleration in the X based on what? Their angle and cosine. Now I put a 1 up there, but if we want to accelerate any faster than 1, we're going to need more engine force. That's where the engine force comes in. Sorry, I missed the equal sign. And like I said, the math functions only work with radians. So this is where pi comes in. And then we'll divide that by 180. That'll give us a conversion to radians from degrees. And then we need a line for the Y. Acceleration in the Y direction will be the engine force and the sine of the angle. That's all we're doing with the key press. We're setting the acceleration. We're going to handle everything else, the updating the velocity, update the position. We'll do all that in the player.update.
So
What?
What's the order of operations here? We're doing pi divided by 80 timetable or what?
The order of operations, I don't know, I just have it written like that.
Oh.
It doesn't matter, it's going to come out the same. If you're multiplying and dividing, it will come out the same.
Right.
So the way this vehicle operates, whenever you're pushing the up key, it'll travel in the direction where the mouse is pointed.
It will apply acceleration in the direction that the spaceship is pointing.
Which is where the mouse is.
No. You may code yours that way. Mine's just based on the player's
with
angle.
The left and right keys.
Yeah, left and right changes the angle,
Got it. That's right,
and then this will apply acceleration in that direction. Now, acceleration we already talked about. It's kind of what is acceleration? Mass, force, F equals ma. So then F divided by m. That's our acceleration.
The mass of this.
One, just one. You can put that in there. You can make it heavy if you want to. But one works out nicely since anything multiplied by one is just that thing. All right, so from there we can go into update. Let's flesh out update and we'll be done with the lecture for today. I'm going to go through this kind of quick. I'm recording it, so if you need to come back and look at it, go ahead. Update. We're going to do a few things. One, we need to check that speed before we get too carried away. So, this is what this is going to do. If we are not going too fast, velocity dot length greater than V max. If we're not going too fast, our acceleration will increase based on, or velocity will increase based on acceleration times delta. Now, maybe your program is angry because you don't have this function. Let's look at that. You could just type this in there. You can take the square root of all the things, but you can also provide this function to your vector file, and that will give you the magnitude or the length of any vector. X times x plus y times y. Take the square root, that's the what from square root. Square root from C math. You may need C math up at the top. Well, what is this from high school or from 8th grade?
That was a long time.
Square root of x squared plus y squared.
What do you have
The vector header file. So Pythagorean theorem. Pythagorean theorem. Y'all guys know this, right, Melvin? Come on, Melvin.
Yeah, I do actually. I've slept since then. I'm still trying to figure out.
I don't believe you. Just tell the truth. No, I don't know it.
No, I do. I honestly I do. I'm just trying to figure out other areas.
I haven't been in statistical math in years.
That is how you find the hypotenuse of a right angle triangle, or the distance, the length of a vector in this case.
Oh,
Can you-
I can't spell it.
Can we go back quickly to
We're going back there. I just want to make sure everybody got this function.
Okay.
And if your square root is angry, it's because you need to include C math up at the top. Moving on, back to player. Boom. All right, we've got that. So we will accelerate, we'll change our velocity if we're not going too fast. That's based on acceleration and delta time. But if we are going too fast, let's slow down. I did not overload minus equals, so I'll have to do this the long way.
Oh, yeah, we need to overload plus equals another vector on flow.
Any overloads that you don't have, you can either go back and fix your overloads, or you can do it like I did it right here, where you just have to type 2 lines instead of 1. So there's our governor. We need to update position now. We know our acceleration, we know our velocity, we need to update the position. Position is updated based on velocity and the amount of time that has passed. Now, all our math, all our vectors are good, but our rectangle is still lagging behind, so we need to update our rectangle based on position. And don't forget to offset it by the half width. That way it draws it correctly where it should be. I like to set the acceleration back to 0 every loop. That way if you let go of the key, it's like you're taking your foot off the gas. That doesn't just happen by default. So acceleration goes back to 0. We can still cruise, but we're not going faster and faster and faster if we take our finger off the key. So that will take care of that. And that's all I'm going to do for today. We'll come back later and we'll do bullets, we'll do rate of fire. We're going to implement a wraparound feature because right now your guy will just shoot off the screen and be lost to oblivion. But wraparound will keep him in check. But you should, at this point, you should be able to go. If you push up, he should kind of move in whatever direction he's facing. And I know it looks like trash through the land school, but this is actually really smooth.
So what's the